All right, so far this has been the most common question for foundational exam number 4. So you're going to see questions that look something like this, where you have some number or variable, equal sign, and then some kind of expression, usually involving a root, so like the square root, or here it's the sixth root of the number. And you're going to be asked, is this a possible expression? Is it valid? Is it truthful? Like, can it happen? And the answer to that question is going to depend on actually the domain and range of some of the functions involved. So I'll talk about domain and range a little bit, but then how to solve problems like this. So anyways, this is one of the weird concepts that we're going to have to learn to figure out what's going on here, is the fact that in math, you can have one function that's secretly 3, 4, 5 functions at once. And that depends on what the function's domain is. So for example, take square root. We'll start with simple examples. If you take the square root of a positive number, you get a positive number. And that's a general rule. Square root of positive is positive. Similarly, if you take the square root of 0, you get 0. And so this isn't really a rule, but you can interpret both of these together as saying that the square root of a non-negative number is non-negative. And then lastly, you don't need to know complex numbers for 6LA, but most of you have heard at some point that there's a number called I, which is the square root of a negative number. It's the square root of -1. And so later on in math, you're going to come across, and I've been getting asked about it, so I think it's worth talking about. If you take the square root of a negative number, that gives you what's called a complex number. And it doesn't matter what that is for this class, but what does matter is the concept of domain and range. So in other words, we have 3 different versions of the square root function. So the square root function is actually a bunch of different functions. And so for example, you could have the square root function where the domain, so these are the numbers you're allowed to hand to the square root as input. If the square root was a chef, these would be the raw ingredients you hand to it. If you can only hand positive numbers to the square root function, it's only going to hand back to you positive numbers. Similarly, if you only hand the square root non-negative numbers, it's only going to hand non-negative numbers back to you. And if you only hand it 0, it's only going to hand 0 back to you. And so for 6LA, either this version or both of these versions of the square root are the ones we're going to be working with. In other words, if a square root of a negative number comes up, we're going to consider that to be undefined, because we're essentially handing to the square root function something it doesn't know what to do with. Like going back to the chef metaphor, this would be like having a chef who is trained to prepare seafood and handing them raw steak to prepare. Like they wouldn't know what to do. Well, they could do something with it, but it's not going to work well with the techniques they've learned. And so how does that help with the homework and the exam problems? So you'll see expressions like this where you'll say, for example, -7 is equal to the square root of -7, because let me write this out. Something raised to the 1/2 that's just the same as the square root of it. So square root of -7 raised to the 2. And normally you can just go ahead and cancel these numbers. Like you've been taught that when you have one thing raised to a power again, you combine the powers by multiplying them. And if we were working in this case, so if the domain and range of, if the domain of square root here included negative numbers, that would be fine. But for this class, the domain of the square root function is not going to include negative numbers, and the square root of -7 is an undefined value. So this would be, I'll put wrong, but this would be, I guess, an undefined equation. Similarly, if you're told that r, a variable, can be any real number, actually here, you can even erase the negative sign, and what we're about to say will still be true. And ask the same question, is the 6th root of r raised to the 6th power always the same thing as r? And the answer is, well, the 6th root of r doesn't even make sense for us, because here we can rewrite this as r the square root of r raised to the 1/3 raised to the 6. So this is another example of an equation that's not really right or wrong. It's just not defined at all. Like the right-hand side isn't even a number anymore. Anyways, but you can have some exponents or some roots that do make sense for negative numbers. So for example, if I have -1, I take the third root of it, and we ask, okay, well, third root of -1, is there a number that we can hand to the third root and it gives us back? What number do we get when we hand -1 to the third root? And this is the same as asking what number times itself 3 times is equal to -1. And there's an easy solution there. That's just -1 itself. It's equal to -1. So for the cube root, we get negative numbers being sent to, I'm almost going off the board here. Negatives. And so negative numbers would be the domain here, and negatives would be the range as well for a cube root. And then the pattern continues in probably the way you'd expect, where the fourth root of a negative number is not defined. The fifth root of a negative number works perfectly well. Sixth root, not defined, and it depends on whether the root is even or odd. If it's even, it's not going to be defined for this reason over here. And if it's odd, then it is defined, because if you take an odd number of negative things times each other, you're going to get a negative thing.